In this video, I am going to show you how to do the 5 questions that you're going to see on the GED math test in which you can't use a calculator. And you might see problems similar to this. Obviously, they won't be exactly the same. So let's look at these 5 questions that I'm going to show you. Let's jump into question 1. It says, what is the distance in units from 0 to b on the number line? So from 0 to b, what's the distance? Before I jump in here, I want to highlight a really important word right here, distance. Whenever you see the word distance, your answer has to be positive because we never measure distance in negative units. So again, when you see this word right here, your answer has to be positive. So any answer choice that contains a negative symbol, or a negative sign, I should say, you can eliminate. So which 2 answers can we eliminate right off the bat? Well, A contains a negative sign right here, so I can get rid of that. And B contains a negative sign right here, so I can get rid of that. And now look what I've done. I just have to choose between C and D, and if I need to guess, my chances of guessing have just increased. And when you're taking the GED math test, you are not penalized for guessing. But let's narrow it down to the final answer. It's asking us for the distance from 0 to b. So here's 0, and here's b. And let me just kind of highlight that so you can clearly see what we're looking for, this distance right here. From here to here. Now, hopefully you can see from 0 all the way out here is a distance of 4 units, right? We're not concerned about that sign. So from here to here, if I was to extend it all the way out, that would be 4 units. So you should see that the distance from 0 to b has to be less than 4 units. So my answer has to be less than 4 units. So any answer that is greater than 4 units, I can eliminate. And 4.5 is greater than 4, so I can eliminate D. And my final answer has to be C, and I'm done. Again, you can kind of double check that. You know your answer here has to be less than 4 units, and my answer is 3.5 is less than 4 units, and I'm done with this. So these test-taking strategies can really help you succeed on the test. Let's go to the next question. It says to multiply 0.431 times 5.6. Well, I'm going to show you some test-taking strategies here as well. Let's say we had this problem, a simpler problem. 23, I don't know, how about 21 times 6 instead? Let's say we wanted to do this one. When we multiply this, the first thing we do is we take the 6 times the 1 right here. And what is 6 times 1? That's 6. So that tells me right away if my problem were to look like this instead of this, I'm just looking at a simpler problem, that my answer would have to end in 6. It would have to. It would have to end in 6 right here. Well, let's continue. I'm going to complete the rest of the problem and show you that my answer will end in 6. Again, okay, so 6 times 1 is 6. 6 times 2 is, this way would be 12. My answer here would be 126, but again, my answer has to end in 6. Well, I'm going to use that same type of thinking to help me do this problem here without a calculator. So let's write this out. 0.431 times 5.6. Let's multiply the first piece of this. 6 times 1. Well, 6 times 1 is 6. My answer must end in a 6. So any answer that does not end in a 6, we can eliminate. And again, this is called the process of elimination here, POE, process of elimination. So which answers don't end in a 6? Well, let's see. A doesn't. A ends in a 1. So see you later, A. And let's see, what about B? Well, B does end in a 6 right here, so I got to keep that one. What about C? Nope, C ends in a 1, so I can get rid of that. See you later. And what about D? Well, let's see. D ends in a 6, so I need to keep it. Well, now I'm getting somewhere. Let's continue this problem. You're going to see I'm actually going to figure out my answer without having to multiply this whole thing out. There's another thing when you're multiplying. If you need to look at the number of digits to the right of the decimal. For example, here's my decimal point right here. How many numbers are to the right or behind the decimal place? Well, hopefully you see there's one number, the 4, two numbers, we got a 3 here and a 1 here. So there's a total of 3 digits or 3 numbers behind this decimal point. 1, 2, 3. So 3 numbers. How many numbers are behind this decimal point right here, or to the right of it, I should say? How many numbers are to the right of this decimal? Well, the number 6 is, so that's one number. So there's one number to the right of this decimal. So there's 3 numbers to the right of this decimal, 1, 2, 3. There's one number to the right of this decimal, one number right here, one number. That's a total of 4 numbers, because 3 plus 1 is 4. So that tells me my answer choice needs to have 4 numbers to the right of the decimal. Well, let's go to B. How many numbers are to the right of the decimal here? Well, here's the decimal. There's 3 numbers to the right or behind the decimal. 1, 2, 3. And I need 4 numbers, so I can get rid of B. See you later, B. I'm done. My answer has to be D. And I don't even need to multiply this out. And you can kind of double check that. You can see that there's 4 numbers to the right of this decimal. 1, 2, 3, 4. And we need 4 numbers to the right. There you go. So let's look at another one. And again, I didn't even multiply this thing out, and we got the right answer. Let's go to another problem, question 3. There's a lot here, and you might want to flag this one. These story problems can be difficult, but actually this one's not quite as tough as it appears to be. Let's read it. It says, Susan and Daphne are participating in a walkathon at the local community college track to raise money. Susan can walk around the track in 4 minutes. Daphne can walk around the track in 6 minutes. Susan and Daphne started walking at the same time. How many minutes will it be until they complete a lap at the same time? A lot here. I always read the final question, R, T, F, Q, on these story problems. Read the final question. So let's do that. The final question says, how many minutes will it be until they complete a lap at the same time? Now, I'm also going to highlight this final question as well, right here. I'm going to highlight this final question. And you can actually highlight on the real test. Why is this important? Because it's telling us what our answer choices represent. Do these answer choices represent laps or minutes? Well, by reading the final question, I can tell. It says, how many minutes will it be until they complete a lap at the same time? So we're dealing with minutes and time. So these have to represent minutes. In other words, 2 minutes, 10 minutes, 12 minutes, 24 minutes. These don't represent the lap. So I'm just concerned when the minutes are the same. And once I find out when the minutes are the same, I'm done. So let's start with Daphne. Let's start with her. Not Daphne, but actually let's start with Susan right here. Here's Susan. So let's see, Susan. It says Susan can walk around the track in 4 minutes. So every 4 minutes, Susan walks around the track. Every 4 minutes. So basically, in 4 minutes, she's walked around the track. She's completed 1 lap. And it's every 4 minutes, so I'm just going to continue to add on 4. 8 minutes. And then what's 8 plus 4? 12 minutes. I could keep going. What I'm just doing is adding 4 each time. So in 4 minutes, she completed 1 lap. In 8 minutes, she completed 2 laps. In 12 minutes, she's walked around the track 3 times. Now, let's go to Daphne next. Now again, I am concerned when the time is the same. I'm not concerned about the number of laps. So when the times come out the same, I'm finished. So let's start with Daphne, or go to Daphne. It says Daphne can walk around the track in 6 minutes. So at 6 minutes, she's walked around the track once. And then I just keep adding 6 each time. So 6 plus 6 is 12. So in 12 minutes, she's completed 2 laps. Boom, the times are the same now, right here at 12. That's the first place where the times are the same or in common. So you should see right away that the 12 is now in common. So their time, right here, it says, how many minutes will it take until they complete a lap at the same time? Well, that would be at 12 minutes because the times are the same here and here. What this really is a least common multiple problem. I'm looking for the first number in common to both Susan and Daphne. And the first number that's in common is the 12. So my answer is C. And again, you could continue this out. What would be next here? This would be 18 minutes. But once I find the first number in common, I circle it, and we're done. So I hope that made sense to you. And again, this is really called the least common multiple if you've studied it, LCM. Let's go to problem number 4. It says simplify. 5 squared minus 2 cubed. Well, this has to do with exponents, and let's go over a little bit of vocabulary here. This number here, right here, this 2. Actually, let me put that in a different color. I'm going to put this in blue. 5 squared minus 2 cubed. That's not blue. Here we go. 5 squared minus 2 cubed. That's how you read that. These little numbers up here are called exponents right here. Let me get my pen right. This little small number is called an exponent, and this 5 is called a base. This 3 is called an exponent. This 2 is called a base. This does not mean 5 times 2. The exponent means repeated multiplication. It's telling us to take the 5, the base, and multiply it by itself 2 times. That's what that means. And this here does not mean 2 times 3. It means to take the 2, the base, and multiply it by itself 3 times. So again, exponents mean repeated multiplication. So let's do this. This means 5 times 5. In other words, you multiply the 5 by itself 2 times. Minus, bring down your minus sign. What do you think this would mean? Well, hopefully you're thinking this means 2 multiplied by itself 3 times. 2 times 2 times 2. Now I'm going to put sets of parentheses around the 5s and the 2. That doesn't change anything. It just makes it easier to read all of this. So what's 5 times 5? 25. And once I've done this, I can kind of drop off the parentheses. Bring down your minus sign. What's 2 times 2 times 2? Hopefully you're thinking 8. And how did I do that? Well, let's think about it. What's 2 times 2? 2 times 2 is 4 right here. And then what's 4 times 2? That's 8. Now I just go 25 minus 8, and we get 17. So my final answer here is C. Let's go to the final question. This has to do with the order of operations. I'm actually going to write this over here. 12 plus 15 divided by 3 times 6 minus 4. And the order of operations, the way we do it here in the United States, and I know different people use different acronyms, but we use what's called PEMDAS to help us with these. PEMDAS. That's an E, by the way. And the way you remember PEMDAS is you say, please excuse my dear Aunt Sally. I'm going to show you how this plays, how this takes effect, and how this is going to help us. But I'm going to rewrite the PEMDAS like this. I'm going to write it like this. PEMDAS. I'm going to write it like this. Still says PEMDAS, but I spaced it out for a reason. You always read an expression from left to right. So the P represents parentheses. The E represents the exponents. That's an E. And I went over exponents in the previous question. The M represents multiplication. The D represents division. The A represents, M represents multiplication. D represents division. A represents addition. And S, that's an S, represents subtraction. Now the reason I wrote it this way, well, before I say that, what this means is when you read it from left to right, you always do your operations in the parentheses first. Then you do your exponents next. Now, with multiplication and division, careful. You don't do the multiplication before the division always. It depends. That's why I grouped these together. Multiplication and division have the same priority. They have the same level. So with this, you do what you see first. If you see the multiplication first, you do that first. If you see the division first, you do that first. Same thing with addition and subtraction. They have the same priority. So you do what you see first. If you see the addition first, you do that first when you're reading from left to right. And if you see the subtraction first, you do that first. So careful there. Let's look at this now using the PEMDAS. So our first operation is plus, then division, then times, then minus. So you should always remember that multiplication and division take priority over addition and subtraction. So I've got this piece right here. Let me just kind of bracket this right here. So I need to make a decision here if I do the division first or the multiplication first. Well, they're at the same level. That's why they're grouped together. So with multiplication and division, you do what you see first, and you read from left to right. So I see the division before the multiplication, so I do the division first. So let's do that. I'm going to do this piece here first, the 15 divided by 3. Watch how this works. Bring down the 12. Bring down the plus sign. What is 15 divided by 3? That's 5. And then I bring down the times sign, bring down the 6, bring down the minus, bring down the 4. Now I have addition, multiplication, and subtraction. Multiplication always comes before addition and subtraction. Remember, I'm going here from left to right when I read this. So I need to do this next. So I bring down the 12. I bring down the plus. What's 5 times 6? That's 30. Bring down the minus. Bring down the 4. And I'm getting closer here. Now I need to decide what would I do first, the addition or the subtraction. Well, they're at the same level. That's why they're grouped together on this PEMDAS. So you do what you see first. I see the addition before the subtraction when I read from left to right, so I'll do this piece first right here, the 12 plus the 30. So what's 12 plus 30? That's 42 from right here. Bring down the minus sign, bring down the 4, and then I just subtract at the end. What's 42 minus 4? That is 38. And that is how I deal with this type of problem. So my answer is C. Well, a lot there. I really hope you found this video helpful, and I really hope you do well when you take the GED math test. Have a super great day.